Welcome to part 1 of our Langflow RAG series. Let's start with the basics. What is Retrieval-Augmented Generation? RAG combines two steps: retrieve relevant context from your knowledge base. Generate accurate answers using an LLM. This approach reduces hallucinations and ensures responses are grounded in real data. In this video, we'll break down why RG matters, how it works, and why it's a game changer for AI applications. Then, we'll preview what's coming in the next parts, where we'll build a full RAG pipeline in Langflow, step by step. Ready to make your AI smarter with real data? Let's dive in. Watch part 2 next. We'll explore why Langflow is perfect for RAG. Welcome to part 2 of our Langflow RG series. Why use Langflow for RAG? Langflow gives you a visual, drag-and-drop interface to design complex pipelines without writing endless code. Connect loaders, embeddings, vector stores, LLMs, and custom tools in minutes. Here's why it stands out: modular design, open source, and integrations with top providers. For speed, flexibility, and a no-code approach to building RAG systems, Langflow is your best friend. In the next part, we'll set up Langflow for your first RAG project. Don't miss it. Welcome to part 3 of our Langflow RAG series. Setup time. First, install Langflow using pip install Langflow or run it via Docker. Next, launch Langflow locally and open the visual editor in your browser. You'll see a blank canvas. Finally, prepare your API keys for LLM providers like OpenAI or Hugging Face. Once Langflow is running, you're ready to build your first RAG pipeline. In the next part, we'll dive into vector stores and embeddings. Don't miss it. Welcome to part 4 of our Langflow RAG series. Today, we're diving deep into vector stores and embeddings, the backbone of Retrieval-Augmented Generation. So, what are embeddings? Langflow converts text into numerical vectors, capturing semantic meaning. Similar sentences end up close together in this high-dimensional space, making semantic search possible. These vectors go into a vector store like Chroma or Pinecone, optimized for similarity search. When a user asks a question, Langflow retrieves relevant chunks by comparing vector distances. This is crucial because without embeddings and vector stores, your LLM would lack context from your documents, ensuring grounded answers and reducing hallucinations. Let's see this in action. In Langflow, drag an embeddings node onto the canvas and choose your model. Then, add a vector store node and select your backend. Connect them together. Pro tip: pay attention to chunk size and overlap when splitting documents. Finally, test it. Upload a sample document, generate embeddings, and confirm they're stored. Next, in part 5, we'll connect a document loader in Langflow. Welcome to part 5 of our Langflow RAG series. Today, we're going hands-on with document loaders. This is where your data enters the pipeline. A document loader ingests raw content, PDFs, text files, web pages, and prepares it for processing. In Langflow, it's simple. Drag a document loader node onto the canvas. RAG systems rely on structured text for embeddings, so proper loading is crucial. Langflow supports various loaders like local file and web loader. Let's build it. Drag the document loader node. Configure your source. I'll upload a sample PDF. Pay attention to chunk size and overlap. 500 tokens with 50 token overlap is a good start. Connect the loader to your embeddings node, then to your vector store node. This converts documents into embeddings and stores them for retrieval. Finally, let's test it. Upload a file, watch the chunks appear, and confirm embeddings are generated. Your pipeline is now ready for real-world data. Part 6 is next, building the full RAG pipeline in Langflow. Welcome to part 6 of our Langflow RAG series. Today, we're assembling a complete Retrieval-Augmented Generation pipeline. We'll connect the document loader, embeddings, and vector store. Then, add a retriever node, linking it to the vector store for relevant chunk fetching. Next, an LLM node for generating answers, connected to the retriever. Finally, a chat interface node for testing. Type a question, and watch the pipeline retrieve relevant chunks and produce a grounded response. Hit run and test it with a real query. Congratulations, you've built your first RAG pipeline in Langflow. Next in Part 7, we'll add an LLM node for contextual answers. Welcome to Part 7 of our Langflow RAG series. This is where your pipeline gets smart. We're adding the LLM node, the brain of the system. The LLM node takes retrieved context and generates a natural language response. Drag an LLM node onto your canvas. Configure it with your API key and model choice. Langflow supports multiple providers. Connect the retriever node to the LLM node. This ensures the LLM always gets relevant context. Use temperature settings to control creativity. Lower values make responses more factual. Once configured, test the connection. If you see a green checkmark, you're good to go. Part 8 is next, testing the workflow with real queries. Don't miss it. Welcome to Part 8 of our Langflow RAG series. This is the moment of truth. We're testing our complete pipeline. We've built a document loader, embeddings, vector store, retriever, LLM, and chat interface. Now let's test it. Open the chat interface node. Type a question like, what is Retrieval-Augmented Generation? Watch as the retriever finds relevant chunks. The LLM then uses those chunks to generate a grounded answer. If you see a clear, accurate response, congratulations. If not, check your node connections, API keys, and Langflow logs. Pro tip, try multiple queries to identify any gaps. If your answers look good, you've successfully built and tested a working RAG pipeline. Next in Part 9, we'll optimize for accuracy and performance. Don't miss it. Welcome to Part 9 of our Langflow RAG series. Today, we're focusing on optimization. Making your solution accurate and efficient is key. First, consider chunk size and overlap. Smaller chunks improve precision. Larger chunks provide context. A good starting point is 500 tokens with 50 token overlap. Next, adjust similarity thresholds. Lower thresholds return more results, but too low can introduce noise. Fine-tune this to balance precision and recall. Also, explore embedding models. OpenAI models are great, but for domain-specific accuracy, try Hugging Face or custom embeddings. For even better relevance, add a re-ranker node after retrieval. This reorders results based on semantic importance. Finally, monitor performance using Langflow's logs and metrics. Optimization is an iterative process. Test, measure, and refine. Pro tip, consider caching frequent queries to reduce cost and improve speed. In the final part, we'll cover deployment, taking your RAG pipeline live. Don't miss it. Welcome to the final part of our Langflow RAG series, Part 10, Deployment. You've built a powerful RAG pipeline, and now it's time to take it live. There are two main ways to deploy your Langflow project. First, export as JSON. This is perfect for version control or sharing. Simply click the Export button. Second, use the Langflow API for real integration. Connect your pipeline to a custom front-end or chatbot. You can send queries programmatically and receive responses in real time. For hosting, consider local deployment, cloud services like AWS, Azure, or GCP for scalability, or containerization with Docker for portability. Pro tip, add authentication, rate limiting, and logging for production apps. Congratulations! You've successfully built, optimized, and deployed a RAG-powered application using Langflow. This is a huge step toward creating smarter, context-aware AI systems.